Hi everyone, we're going to use Rolle's theorem to determine whether it can be applied on the closed interval, and if so, find all the values of c such that the derivative of f at c equals 0. And these are our two problems we're going to do, and these are our closed intervals here. So, the first one is here. I took the liberty of going ahead and foiling this out. This is going to be x cubed minus 6x squared plus 11x minus 6. Notice all polynomials are usually differentiable. So we're going to just go ahead and check our 1 and our 3. You plug in 1. So if I plug in 1 in this piece, this is going to be 0 times all that's just 0. And if I plug in 3 in here, this is going to be 0. And that's going to zero out the other two binomials. So this all equals 0. So therefore, f is differentiable, or it's continuous, on our closed interval, and therefore continuous on our open interval. And then we're going to, since that's the case, we're going to take the derivative of f, which gives us 3x squared minus 12x plus 11. And we set this to 0 and try to factor it, which we can't. So I'm going to use the Pythagorean theorem and plug this in. So we get x equals negative b, so that's going to be 12 plus or minus the square root of negative 12 squared is 144 minus 4ac all over 2 times 3, which is 6, 2a. So this is going to equal 12 plus or minus the discriminant here is going to be 12 over 6. So this is going to be 12 plus or minus, this is 4 times 3, which is going to be 2 square root of 3 over 6, which can reduce to, with this 2, I'm going to make my denominator 3, so this would be 6 plus or minus square root of 3. So I have two values. I have c equals 6 plus square root of 3 over 3, and c equals 6 minus square root of 3 over 3. Okay, the second one we're going to do is f of x equals x minus 3 times x plus 1 squared, and our closed interval is negative 1 comma 3. This is a polynomial. I plug in negative 1. When I plug in negative 1 here, that's going to be 0. And then when I plug in 3 into this one, that's going to be 0. So it's going to zero everything out. Therefore, our function is continuous here on the closed interval, and it's differentiable on the open interval. Now, since that's the case, we've got to find all the values of c. So I'm going to take the derivative, and the first thing I'm going to do is FOIL this out. And when you do that, you're going to get, let's see. Well, I don't think I am. I'm just going to take the derivative. So take the derivative of this, and you're going to get x minus 3 times the derivative of this piece, which is 2 times x plus 1, and then minus this piece times the derivative of the first piece, which is just 1. And since I have 2 of these x plus 1s, I'm going to factor by grouping and write this as x plus 1 times 2x minus 6 plus x plus 1. And basically what I did is I distributed these two and got this, then I added this. Alright, and this should have been a plus, sorry. Now, cleaning this up, we get x plus 1 times 3x minus 5. Alright, so when you set this to 0, we already have negative 1 here. And we're talking about the open interval, negative 1, 3. Usually, here you would get negative 1, but it can't equal negative 1, so we're not going to look at that. We're only going to look at this piece. So we have 3x minus 5 equals 0, so x equals 5/3. And 5/3 is our c, because we want our c to be between negative 1 and 3, which it is. And that's all. Thank you. Have a nice day. Bye-bye.